Hello, dear students. Welcome to the session. In this session, we will discuss about the PERT, that is Project Evaluation and Review Technique, or it is also called as Program Evaluation and Review Technique. As we know that the major difference between PERT and CPM is PERT, a probabilistic approach, CPM, a deterministic approach. As the PERT is a probabilistic approach, the time required to execute each activity or entire project consists of three time elements. Those are optimistic time, pessimistic time, and most likely time. Let us see what exactly these time elements are. The optimistic time element, which is denoted by T suffix O, this is the shortest possible time among the three time elements that require to complete an activity. It assumes all the things goes extremely well. No provisions are made for delays or setbacks while estimating this time. Means by assuming that during the execution of individual activities of a project, nothing wrong will happen. Means no any adverses, any hurdles, any uh, problems will occur during the execution of individual activities. Whatever the time is allotted for each activity, that is entirely based on the time required for execution. The accurate exact time required for execution of the each activity is allotted, and that is why it is the shortest possible time element among the three time elements. Then the second one is, that is pessimistic time element, and it is denoted by T suffix P. This is the maximum possible time the activity will take if everything goes bad. However, major catastrophes such as earthquake, flood, storms, labor trouble, etc. are not taken into account while estimating this time. This is the maximum possible time among the three time elements, and this includes that time element. Pessimistic time element includes the time required for the execution of the activity along with the time which will be consumed by the problems or any hurdles or any adverses which are possibly occur during the execution of the individual activities. So that is why the total allotted in the pessimistic time is maximum comparing to other two, but it does not consider any other randomly causing problems such as the earthquake, floods, storms, labor trouble, etc. Then the third time estimate of this PERT is most likely time element denoted by T suffix M. This is the time an activity will take if executed under normal circumstances. It is the model value. Means the time taken for any activity under normal circumstances is considered as a most likely time element. And this time element is fixed or it is estimated based on the performance of that activity in the previous projects. Means suppose same activity which has been performed many of the times in the previous many projects. Based on that, based on the past data, based on the historical statistics, the time element, that is most likely time element, is fixed. So these are the three time elements are considered for the each activity of a PERT. And based on these three time elements, the expected time will be calculated. But whereas in case of CPM, critical path method, these time elements are not there. Directly the expected time or the project activity duration is given. That is the difference between the PERT and CPM. Suppose if the problem contains activities along with three time elements, that is TO, TP, and TM, then it is considered, or it is identified as the PERT problem. Then the frequency distribution curve for the PERT, you just observe here. We are already familiar with the statistics the standard normal curve or the standard distribution. The here, as there are three time estimates for PERT activity, that is optimistic, pessimistic, and most likely time element. The ranges from optimistic to pessimistic, there can be a number of time estimates for the activity. That is from TO to TP, optimistic time to the pessimistic time. You can have the number of ranges of the time elements for TO, TP, and TM. If a frequency distribution curve for the activity time is plotted, it will look like that standard normal curve which has been shown here. And it is assumed that it follows beta distribution with unimodal point occurring at Tm. Unimodal means at the midpoint occurring at the Tm, that is most likely time occurring at the mid, so that it will be a symmetric. So this can be a symmetric. And the endpoints, both TO and TP, are considered as the endpoint. This TO and TP, these are the two extremities. That is the optimistic time and pessimistic time are considered as the two extremities with a 3 sigma limit, plus 3 and minus 3 sigma limit. The most likely time need not be at the middle, means at the center. It may not be, may or may not be at the center. It may be skewed right, or it may be skewed left, or it may be symmetric also. The expected time or the average time estimates of an activity is taken equal to the mean. So that is Tm. That is TE is equal to, that is expected time is equal to the TO plus TP and 4 times the Tm. That is TO plus 4 Tm plus TP divided by 6. That is 6, which will give us the expected time for each activity. It means, suppose if optimistic time, pessimistic time, and most likely times are given, then the expected time element for individual activity is calculated by considering this equation. Then after finding this expected time, then you can find out the standard deviation. That a standard deviation sigma is calculated as the TP minus TO divided by 6. That is TP minus TO divided by 6 will give the standard deviation of the individual activity. Then the variance of the individual activity, the variant of each activity can be calculated by squaring this standard deviation of that respective activity. That is phi is equal to sigma square. That is sigma is TP minus TO divided by 6. If it is squared, then it will give the variance. Let us take one problem from the previous question paper. So this was asked in May, June 2010. The problem is the below table shows the jobs of a network along with their time estimates. The time estimates are in days. The jobs are given in terms of 1 to 2, 1 to 6, 2 to 3, 2 to 4, like that, and corresponding time elements are given. Please note that A, M, B are given here, and the time elements for each activity is given. So say for example 1 to 2 has got 3, 6 and 15. As we know that the optimistic time is the shortest possible time. So here 3 is the shortest among this. This is the optimistic time, and the pessimistic time is the longest time or the maximum time possible time of 3 elements. Then this 15 is the pessimistic time, and the 6 is most likely time. Sometimes in the problem it is given as TO, TM and TP, or sometimes it is given as A, B, C, or sometimes even they just give the time estimates as 3-6-15. Then based on the knowledge regarding the pessimistic, optimistic and most likely time, we have to identify. It means the shortest is the optimistic time, then the highest is pessimistic time, and the value in between these two is the most likely time. Then next thing is we have to tabulate all the given three time elements against the activities. Here it is tabulated 1 to 2, 1 to 6, 2 to 3, all the activities are given. Then the corresponding optimistic, most likely and pessimistic time are written here. Then we have to calculate the expected time for each activity by using this equation TO plus 4TM plus TP divided by 6. Then the here for this 1 to 2, 3 plus 4 into 6 plus 15, that is 3 plus 24 plus 15 will give 42, that is divided by 6 is 7. Here 2 into 4 into 5, 2 plus 4 into 5, that is 2 plus 20, 22 plus 14, 36, 36 divided by 6 is equal to 6. Like that, the expected time for each activity has been calculated here. Then the standard deviation, that is TP minus TO divided by 6, by using this equation, the standard deviation for each activity is calculated. Here TP minus TO by 6, that is TP is 15, 3 is TO, 15 minus 3 is 12, 12 divided by 6 is 2. And similarly, 14 minus 2 divided by 6, that is 12 by 6, 2. 30 minus 6 is 24, 24 divided by 6 is 4. Like that, the standard deviation for each activity has been calculated here. Then the squaring of this standard deviation will give the variance for each activity. The variant is calculated by using this equation V is equal to sigma square or TP minus TO upon 6 whole square. The square of this 2, square of the 2 is 4, square of the 2 is 4, square of the 4 is 16. Like that, the variance for individual activities has been calculated. Then next thing is we need to, as per the requirement, draw the project network diagram is asked in this problem. Let us draw the network diagram for this activity, this project. We have calculated the expected time here because this expected time is going to be the duration for each activity. So that is why first we need to calculate the expected time. Then we have to go for drawing the network diagram. Here the network diagram has been drawn. 1 to 2, the expected time, that is 7. The 7 is considered as the duration for activity 1 to 2. Then next is 1 to 6. The expected time is 6. Then 2 to 3, expected time is 14. Then 2 to 4. Then 3 to 5. 4 to 5. 5 to 8. 6 to 7. And 7 to 8. This is the network diagram as per the precedence relationship given in the problem, and corresponding expected time duration is denoted on the each activity. Then after drawing this, as usual, we have to calculate the earliest start time and latest finish time for all the activities. Let us make it somewhat expanded so that it will be convenient for us to mention the earliest start and latest finish. Earliest start for the first event, that is event number 1, is considered as 0, 0. Then earliest start for the second is, that is 0, 0 plus 7 will make it 7. Earliest start for the second event is 7. Then for the third event, 7 plus 14 is 21. Then for the fourth event, it is 7 plus 8 is 15. Then for the fifth, here 21 plus 11 makes 32, whereas 15 plus 7 makes 22. Among the 32 and 22, 32 is to be considered because on 32nd day, 3 to 5 and 4 to 5 will be under completed condition. The next sixth, that is earliest start time for the sixth event is 0, 0 plus 6 is equal to 6. For 7, it is 6 plus 11, 17. Then for 8, 32 plus 4 is 36, whereas 17 plus 17.833 will make 34.833. So the 36 is the maximum that has to be considered here as a earliest start time. So 36 is the earliest start time for the last event, 8. Then this 36 itself is the project duration. Then the same 36 has to be posted under the latest finish time because the latest finish time of this project will become the 36. Then after considering this 36 as a latest finish time, then the latest finish time for the remaining events are calculated by moving in the reverse direction, that is backward propagation. For this 8 to 7, 36 minus 17.833 will give 18.167. And for 6, for 5 to 8, the latest finish time for 3 to 5 and 4 to 5 is 36 minus 4, that is 32. And similarly for the fourth, that is 2 to 4, the latest finishing time for the activity 2 to 4 is 32 minus 7, so that is 25. And for 2 to 3, latest finish time is 32 minus 11 is equal to 21. And similarly for 1 to 6, it is 18.167 minus 11, which makes 7.167. Latest finish time for activity 1 to 5 is 7.167. Then latest finish time for 1 to 2 is 40, that is 21 minus 14, that is 7. Then 7 minus 7 is 0. 7.167 minus 6 is 1.167. Then the minimum is 0, 0. And one more thing is it must be 0, 0. So that is why 7 minus 7 is 0, 0. Then by this way, we have calculated earliest start and latest finish time for all the activities. Then let us tabulate these and we'll calculate the remaining two, that is earliest finish and latest start. Here, the expected time activities are written and their expected time durations are written here. Then earliest start time that has been brought from the network diagram. Latest finish time again from the network diagram has been tabulated. Then the remaining these two, that is the latest start and earliest finish, has been calculated based on the values present in the table. That is, latest start time is calculated by subtracting expected time from the latest finish. That is, finish minus uh, time is equal to start. That is, latest finish minus time duration will give the latest start. That is 7 minus 7 is equal to 0, 0. 7.167 minus 6 will be 1.167. 21 minus 14 is 7. Like that, we have calculated the latest start time for all the activities. Then earliest finish is equal to earliest start plus expected time. That is, earliest start is this table, this column. And if you add the corresponding expected time for that activity, then you will get the earliest finish. 0, 0 plus 7 is equal to 7. 0, 0 plus 6 equal to 6. 7 plus 14 is 21. And 7 plus 5 is 12. 21, 11, 32, 15, 7, 22. Then 32 plus 4 is 36. Then 6 plus 11 is 17. And finally, 17 plus 17.833 is 34.8333. So like that, you have calculated all four time elements: earliest start, latest start, earliest finish, latest finish. Then next is total float is to be calculated by using the equation either LS minus ES or LF minus EF, but both should be same. When both are same, then it indicates that the calculation of earliest start and latest finish are correct in the network diagram. Here, LF minus EF, that is this minus this, is equal to 0, 0. This 7.167 minus 6 is 1.167. Here also 1.167 minus 0, 0 is 1.167. Like that, the total float has been calculated for all the activities. And based on these total float values, we can identify the activities as critical or non-critical. As we know that the critical activities are having the total float equal to 0, 0. So here the first activity 1 to 2 has got the 0, 0 as a total float, then it is a critical activity. Then the second activity 1 to 6 has got the total float equal to 1.167, which is non-zero, then it means it is a non-critical. Like that, the based on the total float is equal to 0, 0, the criticality of the activities has been identified here. The first 1 to 2, then 2 to 3, then 3 to 5, then 5 to 8. These four activities are considered are identified as the critical activities because their total float is 0, 0. Then remaining activities are non-critical activities. Then these critical activities have to be marked on the network diagram. Here the network diagram, as 1 to 2 is the critical activity, then 2 to 3, then 3 to 5, and last 5 to 8. and it is become the unbroken chain from the start event of the project to the end event of the project. So the 1 to 2, 2 to 3, 3 to 5, and 5 to 8 is the critical path. Then finally, the project duration. This project duration is equal to 36 days. Then the next thing is, in the problem, it has been asked to find out the probability of completion of the project in 31 days. Here it is asked that find the probability that the project is completed in 31 days. Let us find out this probability of completion of 31 days in the next session. So once again, you go through this for that is regarding the calculation of expected time based on the equation TO plus 4TM plus TP upon 6, and we'll continue to find the probability of completion of the project on the scheduled date, that is 31 days, in the next session. Thank you.